Hello, hello everyone. This is Phase 101, and please tell me if you can hear me. Loud and clear. Okay. Okay, cool. For those that are watching from Facebook, um, just know that on Facebook you have 20 seconds of delay, and also when I paste any links, you will not be able to see them. So the best way is to follow on Twitch. But if you prefer to stay on Facebook, you're more than welcome. I'm streaming it on both Twitch and Facebook because most of the people know me on Facebook. They do not really know me on Twitch. Yeah, today I'd like to finish chapter 1. I tried to finish this in the Italian version. It was impossible. I did actually 2 hours and a half, not 2 hours, as the stream is supposed to be. But I never got, not even close to page 20. I think on page 14. So 6 more pages to go, and I only did 5 pages basically. Last time we finished, we were here. Let me bring my. So we were here last time, where we said that this is a correction. Actually, I had a typo. In the assembler, we do equals, not C as I said last time, but equals R. I just got confused, and I should have noticed it because in my notes, because I have separate notes, I have the notes next to the book, which you guys see, and I have notes separate or related to other things, and it was clear in front of me that it should be an R. But anyway, things that happen. So that's the first thing. So when we go to the assembler, let me bring the Amiga so that I show you again what I'm referring to. So if we do equal R, okay, this will show the registers of the Amiga, okay? You can see them there. And if you, so escape, you exit, and then if you do equals R and 100, sorry, it displays the full details related to BlitCon or BTLCon 0, basically, as most people know it. So that's one thing that I needed to correct. In the meantime, I was asked a question, which I'm going to cover here. Abacus has got an assembler called ESIM Pro. I'm going to write it to show you the difference. It's called ESIM Pro. Okay, it is not the same as ESIM Pro. So it is not the same as ESIM Pro, like the way I wrote it. Those that are on Twitch can see what I wrote, but I assume that people on Facebook are not able to. Actually, maybe I can write it in the assembler. So Abacus has got an assembler called ESIM Pro, but the assembler we are using is, of course, it's going to give me an error when I do it, is ESIM Pro. Okay, that's the difference. There's a huge difference. So the one that I'm using is ESIM Pro, that is a descendant, let's say that, from ESIM 1. It's basically been renamed to ESIM Pro because the guy released it as open source with all the features that he added. I do not know if ESIM Pro of Abacus is compatible with ESIM 1. I haven't looked at it, and to be honest, I didn't even try to load it because for me, I'm old school, and for me, ASIM1 is in a way standard like DefPack is. So ASIM1 comes from Sika assembler, which was the first assembler, at least that I had on the Amiga before. Actually, I had the A68K assembler, which is the Commodore assembler, but it didn't have any editor. It was command line only. But then I remember having the Sika assembler, and then there was the Master Sika assembler. In the meantime, ASIM1 came out, which I had, but I upgraded to DefPack. However, this book is written with ASIM1 or Tresham, which is a descendant also of ASIM1, and I mean, whether you like Seek or not, I mean, it's a different story. I'm saying the book uses ASIM1. Please try to not use rude words. Yeah. So yeah, it's ASIM Pro coming from ASIM from ASIM1. The book talks about Tresham, but as I said, I prefer to use ASIM Pro because it has color highlighting and all that stuff. Let's see if I have other things that I need to before I start. Yeah, if anybody knows how to download a video from Facebook in HD or 720 HP, 720p, please tell me what I need to use. I've used so many tools, but they always download in low res, not just 720. And the first video I made, the first stream I made in Italian is only yeah. I'm pretty sure there's many people that know. I'm pretty sure that many people know Fabio as Randy. I mean, I know him. I talk to him quite often nowadays. So, yeah. If anyone knows how I can download the videos from Facebook, please let me know. As I said, I made a mistake in the first stream that I made in the Italian version, and I only have half of it for some reason. I do not have the full stream in Italian. So yeah, the other thing I wanted to say is that this stream is 1 week in Italian, 1 week is in English. Okay, so on Sunday, 1 week is Italian, 1 week is English. The Italian always comes before the English one. The reason why is because I started with the Italian one. Like that, 2 weeks give me also enough time to prepare myself. I read the book, but I didn't read it for a stream. So I'm trying to catch up with it in terms of for it to be able to be streamed. So it's a different story. And basically the book is being read. I mean, I'm reading it again. I'm making notes. I'm doing it in Italian, and I'm I'm doing it in English. So in a way, I'm reading it 4 times. As I said, also, I do not know more than what the book knows, what the book talks about. So any experts in relation to Amiga, please reflame. I'm just trying to help those that were like me, that did not know the Amiga and just learned, and I'm sharing what I learned thanks to this book. Anyway, let's start to where we were. The last thing we did on the assembler, it was as I said, the arc command from the assembler, which he spoke about it in this part. Okay. He also has a typo because later on, actually, he refers to it as equal R. So that's also from where I made my mistake, I believe. Yeah, it's something that can happen. But it's not a big thing. So he talks about the Amiga manuals, and he says that the Amiga hardware manual is the only one really needed. I make the Italian one also. I can speak Italian too. Please note that I'm doing this with the permission of Fabio Ciucci, okay? And I am in constant, let's say, constant communication with Fabio in relation to this. So yeah, if you want to listen to the Italian version, it will be next week, and it will be episode 3. Okay, this is episode 2 of the English of the English version. Anyway, so he was saying that the hardware manual is the most important book because we're going to use the hardware manual, but the other books, I think he mentions it later on, are not really used in terms if you want to do if you want to program directly the hardware. Maybe you'll use a little bit like execs to allocate memory and things like that. But yeah. By the way, I didn't say hello to most of you. So I'm just noticing people that maybe joined for the first time, like Zep. I know I spoke to Zep some time ago, but yeah, thanks for joining, Zep. Chiklope, thanks also for joining. You've been writing some messages on Facebook. There's some members from my Phase 101, so Crane and Houndock and Raveman. Hi Andy, Magic Knight. Hound is waiting for episode 4. Yeah, I hope I will be in chapter 3 in episode 4, but with this pace, I doubt it. He says that the books, the other 4, I think the latest edition of the Amiga books are 5. From 5, one is the hardware manual. The other 4 are all the other 4 are mostly used if you program in C or things like that. If you're going to use 68000 and you want to program the hardware directly, you don't really use them. Okay, so in fact, I think this part can be skipped. Yeah, here Fabio makes a joke in a way. He says, if you're just interested, because at that time, remember, everybody was copying games. If you're just interested in copying games using Xcopy or some trainer, then, just this is not for you. He also saying that it's very rare to find a woman or lady that can code, but when you find one, normally they are good. Okay. Now he talks about lesson 2. He says lesson 2 is the most difficult for the beginner. We are still in chapter 1, but he's saying chapter 2 is the most difficult because it's actually about the 68000. It's, let's say, the most boring also because although there's lots of exercises, you don't really see a lot happening on the screen. The 3 things start, you start seeing really things on the screen from chapter 3. Although this chapter, and even one example in chapter 2, there is something related to graphics which you will see. So we will use the hardware registers and you will see some effect basically, but nothing special. So as I said, in lesson 3, you will see some. You will start with manipulating the copper, basically. Okay, so here, let me see if this is the page. Okay. Here he explains what an assembler is, and also he explains hex and decimal. Sorry, when I slow down, let's say that from my speeches, because I'm reading also your messages. So I think he talks about hex and decimal. Let me read my note. Okay, what he's saying here is an instruction like RTS, okay, is actually not stored as RTS in the computer memory, but it's stored as a binary number, which normally we don't use binary numbers because it's difficult for us to read or distinguish. So we use hex, and the hex number for RTS, for example, is 4E75, okay, in hex. He is going to talk about now how to write assembly. Give me a second, guys. Yeah. I'm not sure if it was you, Andy, that deleted the message, but or maybe the bot. But if it was you, Andy, let me know. I'm just checking that we don't have the issue that we had last time of the bot by deleting messages or stopping people from posting. Okay, so it was the bot. But this time the bot should not be causing any issues in relation to timeouts and things like that. So if it thinks that you type, because I only enable two things for swear words and if you try to spam, then it should cut. If you try to type lots of messages, it should cut you off basically. So I only have these type of things enabled, nothing else. Okay. Good. If it was a bot that was banned, good. Thanks for verifying that. Okay, so in assembly, okay, you start writing labels starting from column 1. So selling followers, yeah, well, I don't think there's a way of eliminating such posts, no? Let me go to the assembler. So if you see the label here, wait mouse, okay, this is the first example in chapter 1, okay, that I'm showing here, but which I will explain later on if we've managed to finish it. You see the labels always start from column 1 in your text, in your editor or assembler, and they always end up with a colon. I'm old school, I put a colon. There are some assemblers that need it. There are some assembler that gives you the option of turning it on and off. But because I'm old school, I still like the colon, and Randy, as you can see, also used the colon when he was doing this. The other thing is the next, the instruction. Normally, okay, so normally you have a label, space, and then the instruction. Randy is like me, he prefers an instruction to start on a separate line and with a space or tab. So this is the instruction, okay? And then we have the operands, basically, the source and destination. So here is the source address, and this is the destination address. That's how you write, basically. Hi, Magizer. Good evening. That's how basically you write assembly code, the format of 68,000. Some instructions do not take any operands or opcodes after it. As you see, like RTS, and there are others. Let's continue with the book. Let's see if I missed anything from what he said in the book. Okay, he said, notice that a label doesn't have spaces within it, okay, and no special symbols. You can use numbers, but in it, actually, you can use also special symbols, but some assemblers might have issues. So refer to what your assembler says if you decide not to go with as in one. Okay, so labels are actually a placeholder for us humans to know where we need to go into the code. So if I bring back the Amiga, when we jump, okay, we are returning from here, or when we do a branch, in this case, we are returning from here to here, instead of having, because that actually is the address where the move.word is. Instead of typing, the address of where the move word is, we just use labels to keep it simple. I mean, this is things that the assembler help us in the way we write assembly. Labels can also be used not just for as placeholders for code. They can also be used as placeholders for graphics and music. I'm not sure if you can do like kick S. It also depends on your assembler. I don't remember any of the assemblers of the Amiga being able to do plus, for example, 3 or minus 3, or I did not use it. And to be honest, I find that confusing, especially for a beginner. So I'm following exactly what the book does. Thanks, Andy. So yeah, as far as I know, I've never seen it, but I cannot tell, because as I said, it's what my experience only with the book. Outside the book, I'm not. I've only learned what the book says and what the hardware manual says. So those are the only two books that I can really refer to so far. So as he was saying, labels can be used for graphics and for music, where our music is or where our images are, and he says that they are just placeholders. Then the instruction follow, as I showed you. These normally are tabulated. The CPU instructions can't start on the first character. So basically, you cannot start a CPU instruction on the first column of your editor. It's always expected to start in the second. Yeah, you can use dots. That is supported. Yes, that I remember also, and I think he does use them here. I cannot remember at the top of my head. Yes, dots are thanks, Maggie. Dots are supported for local variables. So you can start a label instead of here you have Pippo, you can do it as dot Pippo. And then when you refer to it, you will branch dot Pippo also. As I was saying, there's after the instruction. So in our case, we have a move L. I'm not sure if it's down here. Yeah. So sorry, I was not showing that. It's here. We are here. As you see, after the instruction, there's a space, and then there is the source and destination. For those that use 6502, you normally don't get source and destination. You only get where you are either storing or what you are trying to manipulate. You already have the value somewhere else, like in the accumulator, etc. While the 68000 has the what is called source and destination. So here we are moving the 4 bytes starting at address 10 actually to the 4 bytes starting at address 20 because it's a long word, it's 4 bytes, which I will cover later on here with this clr.long. .l means long, means we are clearing the 4 bytes starting at address 10. In my notes, I put a note for b.w and .l. So an instruction, I'm not going, an instruction can take .b for .byte, .w for .word, and .l for .long. So .byte is 1 byte, .w is 2 bytes, and .l is 4 bytes. There is also .s, which I didn't put here, and I do not want to confuse, which is when doing branches, but I will cover that later on. I will go into a bit more detail about this. As I was saying, some instructions do not have anything behind them, so it's like the RTS. With what I forgot to mention is comments. Comments can start at the first column also, like label, and can also start after the instruction and source destination after you've done your instruction, basically. So like if I go on the Amiga again. So here he has lots of comments, okay, starting from column 1, but he also have comments starting after the instructions, okay? The semicolon is indicating that this is a comment, and if you notice, all the comments are in green because of the way the assembler was, let's say, I changed it because I wanted a black background and text and comments in green, etc. But yeah, that is my choice. Let's go back to the book. Here he gave, I didn't put any comments, but I'm just going to cover it. Here he, first of all, can you see it clearly? Because maybe this is, because I'm noticing that this text is smaller than the other one. Here he's showing, it's just, for example, it's not that he's really doing anything. So this is just, how to say, example code. He's moving from address 10, the 4 bytes, to address 20, and he's clearing from address 10. Both of the instructions are long, so 4 bytes each. And he's showing what he is trying to emphasize is actually that this instruction takes source and destination. This instruction takes only, let's say, destination, doesn't have any source. And this doesn't have neither source nor destination, okay? That's what he's trying to show there in the example. So now he's going to explain what an assembler normally has. He's saying that you normally have an editor, a monitor, and a debugger. And he's going to explain each one of them. So, I mean, the editor is common sense, is where you write your assembly, okay? You save your assembly, your source code .s. Normally it's .s on the Amiga, but you can also save .asm, .asm. It's your preference in a way. I prefer .s. Okay, there are other extensions like .i, etc., which are used for other things, which you can encounter in the include files of the Amiga, but I'll cover those later on. He's saying we use the monitor to see the contents of memory, disassemble our code or someone else, and see how it is in memory. And basically, a monitor, he's saying, and this is one of the things, the nice thing of a monitor, we can see that here, we can see that the monitor will show us the address, sorry, not the address, the hex value of RTS that the CPU uses to store in its memory for the instruction. Remember, the instructions of the 68,000 are always 2 bytes, okay? And they have to be also aligned at even addresses. It's very important. I think later on I'll make an emphasis on it, but I just mentioned it because it came to my mind. The debugger helps you or helps us to debug the code, of course. It permits us to execute instructions at a time and see exactly how the program is behaving to locate bugs in our programs. Yes, yeah, I think if you try, it will not be a bestseller. I think it's a guru in the Amiga terms. I mean, as far as I know from what I've learned so far, maybe Megizer can confirm that. Trying to use an odd address, I'm pretty sure the Amiga throws up a guru, at least from my experience so far, which I made many times. When you're starting, it's a common thing. You either forget a 0 at the end of some text, and then you end up at an even address, or you forget the even instruction, not directive, sorry, and things like that. Yeah, yes, it is a bus error, but the Amiga throws a guru. Yeah, you're right. It doesn't. To be honest, it's good that you mentioned this, because it doesn't tell you it's a it's a bus error. Actually, it just says guru, and for whatever reason. He also says that the assembler has got also a linker. This is when you want to link your code to some external library or some other things, somebody written something in C and makes it available as an object to your for you to use, and you will can link to it and can call libraries within that code. So basically what he's saying is, let's go. So here, this is the editor. Okay, so if I do assemble and then I do J, so that's the example of, I should not have showed you that, but yeah, that's the example of chapter 1. So if I do D, and Is it initio the first? I think it's initio. The first label. No. Oh, wait, mouse. I can type. There you go. That's disassembling the code. So as you can see here, we have the move instruction here is 3F9. Then we have the address, DFF006, which you can see it here. And then we have the address DFF180, which you can see here. Okay, and it continues like that. As you can see, RTS is 4005. This is memory that we are not using, and it is all 0 in this case. It doesn't mean it's always 0. And this is the address which the assembler allocate to us, or give us, because the Amiga is dynamic. Your program is loaded in memory, depending what the OS decides. Unless the only thing that you can specify is whether it's chip mem or fast mem, or both. It depends, which I'll cover also that later on. But yeah, in this case, the program is loaded at 4018795C basically. So that's the disassembler, and then there is there is a memory dump also, I believe. Yeah, that's a memory dump. If I specify the address and the monitor, I forgot the, but I can, yeah. That's to be able to, you know, assemble the code, debug the code, which I will not go into that yet. Just wanted to show them to you, all three. Other assemblers has got the same thing. I mean, if you use DefPack, has got monitor, has got a debugger. I think the monitor is also a debugger. Monam, if I remember correctly, and DefPack is the assembler. And then both of them has got a linker. If you notice that I made any mistake, please correct me. I do not mind being corrected. Okay, I mean, I'm human. I can make mistakes, and I can also, you know, I could also have misinterpreted something in the book, which misinterpreted wrongly. So the next one, he's saying that he's going to base this book on Tresham 1, which is, let's say, an upgrade of ASM Pro. Not sorry, of ASM 1, but as I said, as I mentioned earlier, it's ASM Pro, which I will be using. And in fact, I made a mistake. In my notes, I wrote ASM Pro as the one of the one I was mentioning earlier of Abacus. So I should correct that in my notes. Actually, let's do it right now. Okay, so he also explains, this is an important thing, how to search in your code. Basically, when your code grows and your source becomes very long, you need a way of searching into your code. So basically, if you do good one, I forgot the instruction. I need to go back. Not the instruction, the command. Okay, if it was a real Amiga, it would be write Amiga plus Shift plus S, okay? But because I'm using the emulator, it's write Control plus Shift plus S. And if, let's go back. So write Control plus Shift plus S, okay? That's the search. And the key show, I have the key that shows you that, you know, what I really pressed. So if we want wait mouse, it should find it. Well, it found it lower in the source. But yeah, just to give an example of how to use that. Okay, so this this text here, I'm going to skip. He's talking about how you assemble on Amiga and how the difference between assembling on Amiga and MS-DOS. Basically, we are not interested in that part. I mean, it would have been interested during that time, but not anymore. At least I do not see the benefit of that. Here he continues to cover some important commands of the assembler. And actually now this time I'm going to move it because I need to see it. So what he's saying is A assembles, okay, J executes it, R read the source, okay. So these are all the sources you can see. Chapter 1 only has one example. Chapter 2 has all these that start with 2, and then 3 has got lots of examples, and it continues. And each one of them, and this is what really made it hard for me for the book. Each one of them has got like another book as comments, which I will go through and explain what he's saying, because of course many people will not understand this. But yeah, and he goes into detail. That's why there are two versions of the book. One is just the text, and one is the text plus the sources. More commands that he covers is WO. So after we assemble the code, okay, if we do WO, we can write the binary file of our code as a file in the Amiga. So WO means, you know, create our exe file, basically. And J, as I said, runs the code, which I showed you, but I do not wish to run it. Escape, we move between the editor screen and the command line. And search, we covered already. So those were all the commands that he covered so far. There are much more commands. In the end, I have made a summary for this chapter, and I also have made like a sheet with all the commands related to the ASIM Pro. But till we arrive till the end of the chapter, I will not be sharing that. For now, it's just for you guys to follow. So let's bring the book back. Now he explains that the heart of the computer is the CPU. Although I think, yeah, the heart is the CPU, but the custom chips of the Amiga, I consider them also as part of the heart of the Amiga. But yeah, it's the one that manipulates everything. So yeah, it's what really executes the instruction and what makes the custom chips do something, basically. Here the book mentions also the move instructions. Is instruction again. I mean, the move instruction is one of the most common instructions that you will be how to say, be using. Okay, Uh, it means move the value from an address to another address. Here I put an example for myself, move address from address 10 to address 20. I didn't specify .s, this I did it intentionally, okay? I didn't specify .s, .w, or .l. So the default is .w, okay? So I'm moving a word, so 2 bytes, so from two addresses, so address 10 and address 11 to address 20 and 21. Remember, each memory address is 1 byte, okay? So when we are moving a word, we are moving memory address 10 and it's .byte. Did I say .s? It's .byte. Yeah. S is for short jump. Yes. .s is for short jump. Yes. I agree, Andy. Yes. So another instruction is clear, which he mentioned earlier. So basically, he's repeating himself so that whoever is new to the assembly on the Amiga, he can, by repeating certain things, you get to understand. I know it can be boring for people that already know it, but it's a way of learning. And actually, this is a technique that we use for, for those that do not know, I teach children how to code, whether it's Python, whether it's HTML or CSS or Scratch, and through the Raspberry Pi Foundation. And this is how most of the exercises are done. So you start small, but the second exercise repeats of the first one and adds something. So basically, the book is doing the same thing. It's a way of somebody that doesn't know anything learns. Okay, so this is an important thing which, honestly, I've encountered people saying lots of, I don't want to use the word stupid things, thinking that they know what they are talking, but I'm sorry to say they do not. Okay, first of all, the Amiga 500, okay, does not have more than 512K chip RAM. Okay, I wrote megabytes, but actually that is chip RAM. Okay, that's a mistake from me here. I know that you can change some chips on the A500 depending on the motherboard that you have, and you can have more than 512 kilobytes of chip RAM, but that is not the standard Amiga, okay? The standard Amiga 500 only had 512K of chip RAM. And there is no, although Commodore calls memory that is not, how to say, that is not shared between the custom. We covered this earlier, okay? In the previous stream, I said that there is chip mem and there is fast RAM, okay? And we said chip RAM is memory that is shared between the CPU and the custom chips, okay? Or the custom registers. Let's put it this way. But it doesn't mean that the memory that is not shared, okay, with the custom chips is faster. It's not. It's the same. It's the same thing. Okay, it's the same speed. The only thing is it's not being shared by the custom chips, and the way it's done, like the VIC chip on the Commodore 64, odd and even cycles, or sorry, big, not odd and even. Trailing, I forgot what is the name, but on going up and going down of the pulse, it changes what it reads and what it writes, something like that, for those that studied electronics like I did. But yeah, so yes, the Amiga 500 can have, you can expand it with another 512K kilobytes of RAM, which makes it 1 megabyte, but the RAM is called, well, it's called slow RAM. They invented these names, but for me, it's actually, you call it slow RAM, fast RAM. It doesn't mean anything except that it's not being shared by the custom chips. If somebody knows a better explanation of this, please let me know. But as far as I know, this is the correct. I think the wording to what Commodore used, it was confusing in terms of terminology. Fast doesn't mean that the RAM is faster. It's not. And slow doesn't mean that it's slower. It's not. It's just not being shared by the custom chips. That's all. The other thing is the 500 Plus has 1 megabyte. Isn't fast RAM on the main board and slow RAM on the expansion bus? It could be, Andy, but in terms of memory, that's what I am trying to say. In terms of memory, is the same speed, because I've seen somebody writing in one of the Facebook groups saying that, well, if you have fast RAM, your Amiga is faster. It's not. I mean, so if you have slow RAM, your Amiga is slower. It doesn't make sense. Okay, that's what I'm trying to refer to by me saying fast RAM or slow RAM. It's a way of distinguishing between custom chips being used and not being seen by the custom chips or not. In fast RAM or slow RAM, the custom chips do not see that type of RAM. They do not see it. Only I will be mentioning the addresses. I remember, I think, if he's still here, McGeezer, I think he had a good video about this, about the memory map of the Amiga, and where he explained how the memory of the Amiga. Actually, I'm going to share a memory map, but I think McGeezer in one of his slides, on one of his videos with slides, he had a good explanation of this. The other thing that I want to continue to say in relation to this, okay, is that the 500 Plus and the 600, they have 1 megabyte of chip RAM. Okay, they can be expanded to 2 megabyte of chip RAM, but they come with 1 megabyte of chip RAM. Okay, they can see 2 megabyte, but they come with 1 megabyte. Okay, and the Amiga 1200 and the Amiga 4000, okay, they have 2 megabytes chip RAM, okay, and they come with it. They come with the CPU sharing the for 2 megabytes, sharing the custom chips with the memory of till 2 megabytes as standard. So I'm talking about standard Amigas, not somebody that modified the Amiga to have more or something like that. Also, please note the WinUAE, okay, let us have up to 8 megabytes of chip RAM, okay? That is not a real Amiga. There is no Amiga that has 8 megabytes of chip RAM or 4 megabytes of chip RAM, okay? It was the intention of Commodore, as far as I know, at least the 4 megabyte, to have 4 megabytes of chip RAM, but they never released the chipset that can do that. So the maximum that on real hardware, what you can have is 2 megabyte chip RAM. I personally, on this version of WinUAE that I'm using 8 megabytes of chip RAM. And I also gave my Amiga 512 megabytes, okay? But it's because I just, when I'm using things, I do not want. Yes, I had shared the documents of of where you can download them, where you can download the book, and it is, I try to find it for you. I should have it here. Those on Facebook cannot see the link. Unfortunately, you have to be on Facebook. Is only one way. Facebook works the way you do streamings is only one way for some reason. I do not understand why it is like that. I mean, and they want to become the #1 stream platform or whatever, but I can see the messages, but what I type, you cannot see it for some reason. Don't ask me why. But when somebody types messages, the others can see it. The only thing is they cannot see mine. But I'd like to thank all those that joined this stream, because I'm seeing that there are many people that has joined watching on Facebook. And I would like to repeat that if you want to, because on Facebook there is a 20 seconds lag for sure. If you want to really follow exactly, please go on Twitch and follow follow Twitch. If you like what you see, just follow me. What can I say? Let me get my other notes. Where were we? Yeah. So after I explained the Amigas, how they had chip RAM, what I want to specify, and that 2 megabyte chip RAM is still address 200,000 hex. Okay. So if you have an A500, okay, the chip RAM you have till 80,000 hex. Okay. If you have 1 megabyte of chip RAM, that means you have till 100,000 hex. Okay. So that is A500 plus A600, A2000. Okay. If you have 2 megabyte of chip RAM, then as I said, it's 200,000, and it is the A1000 and A1200. The Amiga 3000, I believe it had 2 megabytes. I believe it had 2 megabytes of chip RAM, but because I've never used one myself, I didn't look it up. I left it out, I have to say. But I believe it had 2 megabytes chip RAM, the Amiga 3000. Here it's not mentioned. In fact, the book specifies till recommends that all the code was tested on A500, A500 plus, A600, A1200. There is no A2000, there is no A3000, and there is no A4000. All I can say that I tested the examples on A4000 because I have an A4000 myself, and they do work. So that's all I can say. I cannot guarantee anything on the other machines. As I said, this one is saying chip memory and custom chips, they share memory, and when you are in this address range, okay, so when you are in a memory range of less, if you are on an A500 of less than 80,000, so from 0 to 80,000, okay, hex, is chip RAM. If you are in a memory location lower than 80,000, that means you are using chip RAM. Your program is in chip RAM. Okay, thank you. The A3000 has only 1 MB of chip RAM. Okay, I didn't know. Thanks, Haudong, for telling me. Okay, so the above, so he's referring at these two instructions, okay? This instruction. He's saying that this instruction, okay, is doing something in memory on chip RAM, okay? Notice the addresses 150,000 and 1A0, okay? So that is chip RAM addresses. Of course, the Amiga 500 doesn't have it. The Amiga, I mean, I'm talking unexpanded standard machines, okay? The Amiga 500 plus and 600 don't, but the Amiga 2000 does. So that is an instruction which is using chipmem. Okay, so here he talks about more about RAM for the Amiga. So he again repeats that 200,000 upwards is fast RAM. Okay, on old Amiga 500 he repeats that above 80K, okay, hex is also fast RAM, but and below is chip RAM. Uh-huh. Thanks, Raveman. You can verify this. I didn't do this, but I believe what he's saying. Okay. You can verify this with sysinfo. So sysinfo will tell you what memory, where is chip mem and where is fast mem basically, or slow RAM if you want to call it slow RAM. Yeah, it will show them as blocks of RAM. Okay, so this is another topic where the kickstart ROMs are, where they occupy in memory. Okay, the reason why, first of all, the reason why he's covering this is because when you are coding on the Amiga, you need to know whether you are in chip mem or in fast mem. You need to know, as I'm going to cover now, where the kickstarts of the Amiga is. So if you have a kickstart 1.2 and 1.3, you are at the location FC 0000, okay, hex, okay. And if you have kickstart 2.0 and 3.0, you are at location F8 0000. I do not know where 3.1 is. If they used, I think 3.1 uses the same as Kickstart 2.0 and 3.0, but because when the book was published, 3.1 did not exist. Okay, he talks only till 3.0, and in fact, the Amiga, I mean, my Amiga 1200, okay, did not come with a kickstart of 3.1 or 3.14, but with a kickstart of 3.0. I did upgrade to 3.1, and then I did upgrade to 3.14. So yeah, initially the 2000, I don't know if later models had 3.1 of the 1200, but my model, because was one of the from the beginning, basically as soon as it came out, I bought it. It had 3.0, and it's still functional after 35 years or more. Okay, so now he's going to explain where the custom chip registers are. Okay, so Raveman, you're telling me that 3.1 was released during ESCOM. Okay. Okay, so mine was definitely Commodore. But yeah, I think I bought mine either end of 1992 or beginning of 1993. So yeah, I can't remember exactly, but I know that I had bought the GVP for the GVP A530 for the Amiga that I had, and then I went, and then the the A1200 came out, and I went and bought also the A1200, and they were like 1 month apart. I remember when I bought them, and at that time I had a girlfriend, and she was complaining so much because we were trying to buy a house or whatever. Whatever. Uh, History. I do not regret that I bought the A1200. Anyway, the hardware registers, okay, of or the custom chip registers, those of graphics and sound start at DFF000, DFF000, okay? The range of them is from DFF00 to DFF1FE. Normally, I take a break after 1 hour of stream, but I'm trying not to take a break and try to get as much done as possible. But I'm not sure if my voice will permit me not to have a break. um, I do not know if the A4000 had 3.1 also. Maybe the ESCOM one, yes. The one that I have is definitely not ESCOM, it's definitely Commodore. The A4000 that I have, and it still has, because I haven't upgraded it, 3.0, doesn't have 3.1. So after this paragraph, I'm going to bring some links and show you certain things. But what I want to say is that, again, he does the equal C here, you see, and I made the same mistake. It should be equal R. Anyway, the address range for the custom chips, graphics and sound only, okay? So anything related to graphics, anything related to sound starts at DFF00 to DFF10E. You can see the registers with equals R. I have another mistake here. That should be an R. Another thing about the hardware custom chip registers, you can refer to them with just the last three numbers, okay? 3 hex numbers. So as I showed you in the beginning when I typed equals R100, okay, which is BPL con, okay, BPL con 0. We normally refer to registers with these last three numbers, okay? In fact, you see this, I'm going to show you in a minute, this several times. So VPOS, as you see here, is 006. You can refer it as 0. You can always assume that there is DFF, okay, in front of that number. And in fact, the copper assumes that all the time, okay? The custom chip registers, there are two types, those that are read only and those that are write only. So most of the time you see W or R behind them to tell you whether it's a read or whether it's a write. Okay, let's bring the links that I have. So first of all, this link here, I'm going to type it, share it in the chat. This gives the timing. Oh, what did I share there? Ah, that I should have shared. Okay, this gives the timing of the instructions for the 68,000 for those that want to go in detail about the 68,000. And this link was provided to me by McGeezer actually. So thanks to him that I have this link. There is no, or at least I couldn't find a good page with the instructions of the 68,000. Okay, but I found this page that discusses a little bit the instructions of the 68,000. Okay, it's not what I really wanted. I wanted like something like what you find for the Commodore 64, but there isn't one like that. So this is for the 68,000 instructions. Here it explains the instruction and also shows you the binary number and the hex code for the instruction. Okay, so only ADDA. Some instructions, instead of writing add, you have to add, you can add another letter to it, but normally that is not understood. It's an address, we're specifying an address there, so the assembler will ease that for us, and you don't need to write the A. Okay, so don't get confused if you see some instructions having these extra, for example, this one, which means immediate, okay, has I. You don't need to specify the I. You can write it as add.b, basically. This one is for hex. I will cover these in a bit, but is how to convert from hex to binary or decimal. So here is, I mean, you're seeing it in big. I mean, I zoomed it out so that you guys can see it better. But let's see if I manage to make it smaller. You should be able to see how to convert. And basically, here's a table. Hex number starts from 0 to 9, and then for 10 you have A, B, C, D, E, F till 15. Basically, binary, you have the explanation of the binary number and the decimal value of it. I will go in a bit detail later on. This is a website the only website that I found that explains the instruction set of the 68,000. It's not as detailed as I would wish to, like there is for the Commodore 64, but it does help. I do use it, I do reference to it. So that's another link. Those that are on Facebook, you need to jump to Twitch to be able to see the links. I'm sorry, but Facebook is only one-way communication. It's not two-way for some reason, so you cannot see the links. And you should be able to see the link of my Twitch on my profile. Definitely, you should be able to see it. Then there is this is the official Motorola programming reference manual for the 68,000. Okay, so I'm going to put a link for it also. Here, this is the memory map of the Amiga, okay, as in the Amiga coding webpage. You'll notice, okay, that from here onwards, okay, which is up to up here 1FF, it's 2 megabyte of chip RAM. Okay, so from here onwards is always fast RAM or slow RAM, depending how you want to call it. It's just keep that in mind, that is memory not accessed by the chip, custom chip registers. And then the A1000, as you can see, had only 256. Okay, it can be expanded to 512, but as far as I know, it cannot have more. Andy? Yeah, I'm going to share this page. So you are ahead of me. Yes, I have this page. You'll see it in a minute. Okay, but yeah, thank you, Andy. So uh, so yes, the also here it explains at the top, it explains how much chip RAM, okay, each machine has, okay, fast RAM and the kickstart ROM, how big it is. Okay. Initially, the Amiga had 256K of kickstart, then it was expanded to 512. But actually, I believe the latest ROM can take up to 1 megabyte, but someone needs to correct me on this, whether I'm right or wrong. I'm not sure. 3.14, I think, is 1 megabyte, or is still 512 kilobytes, but has room for 1 megabyte, because the Amiga can support up to 1 megabyte, I believe, of kickstart. But please correct me. I'm really stating this from the top of my head right now. Here, this is from the Amiga hardware manuals. Okay, this is the web page that most of you need to know. If you do contents here, we go to the this is all the Amiga hardware, all the Amiga books. Basically, you have them. Actually, this is the hardware manual. So if I go back, Amiga developer docs, these are as you can see, CD version 2.1, OS 3.5, and this is the documentation. And one of them is the Amiga hardware reference manual. And basically, I was showing you a link of the custom registers. This is also the same thing what the assembler displays if you do =R. Okay, maybe it's not updated as here, but yes, it does. So that's the other link. Then there's on the same book, there's the opposite way. So if you want to see just the register, if you know the name of it and you just want to know, so for example, BlitCon 0, BPLCon 0, which is 100, okay, you can see it's 100, and in this text it's explaining both 100, 102, and 104. Okay, the custom chip registers are always wired aligned to basically 2 bytes. Let's put it this way. So here's another link for the same page. Then I like this page. This page, I think, is better than the one when it comes to the registers than the one that is from the CD version 2.1 or OS 3.5, because this page also tells you the registers which are AGA. It tells you, you see it here, it tells you which chipset, so original chipset, OCS, extended chipset, and advanced graphics, and I forgot what it means right now, what it is. Advanced graphics AGA chipset basically. And here, as you can see, it tells you whether it's read and write. I forgot what it stands for, but I'm pretty sure somewhere it's written what it stands for. So I prefer this page when it comes to the, I think it's more updated, but it's the same like the hardware manual. So Control C, I'm sharing it again. And this is, hold on, did I share this one? I did. Then here, this one. Okay, this is a document that I found. I think this is an old document, but I think it's quite a good one. So this still talks about Zika, as in Pro, as you can see here, talks about the old assembly, but there are things that he covers that are quite interesting. I haven't read it all, okay? For example, he talks about how to convert from ASCII to decimal to hex, decimal to ASCII. It's quite an interesting document, and how to open to do simple things on the Amiga, basically. He is using the libraries here. He's not using the hardware directly, but it's good. It's a good manual, let's put it this way, or document that I came across. Sorry. So that's another one. And as Andy pointed out, there is that link which I was going to show. If you noticed my PDF, I have 68,000 instruction set, which was that link, and I have it here because what I do sometimes I do Control F and I search the instruction. So I find it quite handy, this document, the same link that Andy posted. I'm just going to post it again just in case. Okay, so those are all the links that I use or that I've used for this chapter. You don't need them all, of course, but it's good to know, and you will need one or two open at one go. Okay, so guys, as much as I would love to not take a break, I have to take a break because my mouth is not just dry. I feel I'm today I followed what Hound Dog has recommended me a straw to drink, and actually I was drinking while talking to you guys, but still I need to take a break. Andy, I'm on a diet. I cannot drink beer right now. I'm not sure for how long. I'm not going to take a beer because this lockdown is going to make me mad also, but that is another story. Yeah, so guys, bear with me. I'm going to switch on. Give me 5 minutes and I should be back. Hello again. Okay. So, where were we? I hope that information. Can you hear me first of all, just in case? Yeah, I just took a break, but yeah. Let's continue. I really would like to finish this chapter, but I know I'm not going to. What page are we? Page 13. So yeah, in the Italian version, I only arrived at page 14, I believe. So yeah, it's going to be roughly the same thing. Okay, so we were talking about the custom chip registers, and we just discussed the ones for graphics and sound. Okay, but there are more custom chip registers which start at BFE 001 to BFE F01. And also, actually, I think it should be 0. But anyway, let me see what he says here. I think it's 0. It's me that made the mistake there. 1FE 00. So yes, DFF 00. So yeah, that should be DFF. And I know I made this mistake. Before I started, I was correcting certain things and I edited the wrong place. To BFE FO, BFE 1FE. So Sorry guys, I'm just reading to make sure I'm not making any mistake in the way I'm passing the information. So DFF1FE. So not B, so it should be D. And again, DFF1FE. Hold on, he's talking about the other registers. No, I'm mixing things. Sorry. Yeah, I should be reading down here. That's where we are. I was reading up here. Oh God. Sorry, I confused you. So that was actually correct. BFE 001 and BFE F01. BFE F01. Okay. So the CIA registers or other custom registers, these has timers in them, has control floppy, control ports, joystick, mouse, and all those things. So these are the custom registers related to things related to the, let's say, hardware in as such. Like, as I said, the floppy or the parallel port or serial port or things like that. So the most important thing that what I forgot to say is that there are two of them, CIA-A and CIA-B, and B starts at BD000 to BDF01, okay? Now, what you need to keep in your mind when you are coding is that when you see something in memory, or you see something referring to DFF and whatever the number, or BFD, whatever the number, or BFE and whatever the number, you know that you are accessing the custom chips, okay? These are registers, memory locations where the custom chips are, basically, and you're accessing their registers. Like if you had a Commodore 64, you know that, for example, the VIC starts at D000, and you are accessing the registers there for the VIC. Same thing for the Amiga. As I said before, you do not need to worry where your program is stored in memory. The Amiga or the OS will take care of it, or the assembler in this case, when it's assembling it and you're trying it, it will be assembled in the right area, basically. If you notice, when you start the assembler, it will tell you where does your code. Let me show you, just in case. So if I exit the assembler, by the way, exclamation mark twice, you exit the assembler. So as in Pro, when it starts, you get an option of, say, chip RAM, where your program is. I'm using I would say I'm using the same terminology that the actual hardware manual also uses. For the hardware manual, the CIA chips are custom chips. So when they talk about the I forgot which chapter it is. I think, is it chapter 7 in the hardware manual, when they talk about the floppy drives, etc. It is for Commodore. It was, you know, it's like you're programming the custom registers. But of course, everybody refers to the custom chips as what we know for graphics and sound. So yeah, those are the most common. Let's put it this way. And when you are accessing the other other hardware registers for the mouse, let's say, or joystick, because that's what we really do in these days. We don't write any more loaders for the floppy or things like that. It's not really done anymore. Everybody has got a hard disk attached to his Amiga nowadays, or in his within UAE. So yeah. No, it's fine, Zextra. It's fine. I mean, it's good point what you just said. So yeah, I'm trying to stick to the book, but also not to deviate from what I think the book is quite correct, because I think the book was built up on the hardware manual, the way it was written. It's just that the hardware manual doesn't have examples, and while this one has, and it has a lot. So yeah, don't worry for saying that. I was saying the assembler will give you 4 options. Okay, chipmem to select where the code goes. So telling it that you want your workspace. Where is it? It's telling it to go in chipmem or go in fastrem or go in public. Public means if you have fast, give me public, give me fastrem. Okay, but if you don't, again, give me chiprem. So the assembler will decide, while here you specify exactly which one you need. Or absolute. You can also do absolute like what you do on the Commodore 64, but it's not the right way of coding on the Amiga. Actually, I've never seen a program which doing, unless you have a loader, unless you write your own loader, I think, I do not see the point of doing absolute, because the OS will not like it, you know, because the OS will do alloc mem, and if alloc mem doesn't return where that absolute is, I think you'll have an issue there. But yeah, and here you're specifying the workspace for your source. So yes. In fact, the assembler has got directives to say where certain things go in memory. For example, if you're doing something with the copper, or you're loading an image or something, or creating a screen, you have to tell it this has to go into chip mem. Okay, and and the assembler has got directives to tell the assembler to do that. But we are talking far ahead now. It's like, because I read the book, I know what it's going to say, basically. Where were we? Okay, so here he covers some instructions. So here he says that there is addition and subtraction, and he gives an example of sub immediate 10. So basically you're deducting 10 from something. Okay, he doesn't give the full example, so I just stayed here. Actually, he gives, actually I should have written it. He gives subtract 10 from energia, which is energy. But yeah, it means subtracting hash. When you see a hash in front of a number, it means an immediate number. It means the actual number. Okay, it's not a memory address. You are actually telling the assembler to use that number. Like addition and subtraction, there is MULS and MULU. So these are multiplication, but S means signed and U means unsigned. Okay, and the same thing there is for division, basically. In fact, the Italian version, I arrived till this. I have a note here. Look, episode 2, Italian version ended here. So this is the last thing I did on the Italian version. Logical operators. instructions or and then not. Yes, they all use the CPU. So div and multiply, they use the CPU instructions. Yes, they are built into the CPU. Of course, they are slow instructions, not like if you had to write your own multiplication or division using shifts. It's not the same thing. But yeah, the 68,000 is a complex CPU, so it has it. There is jump and JSR, okay, same like the 6502, okay, and this means that you can jump anywhere or have a routine anywhere in memory, okay, and the jump to subroutine also expects an RTS. But the 68,000 also has branch BRA and branch to subroutine. This is relative, and it gives you the option of going minus, let's say, I think it's a word, so it's 16K upwards and 16K forwards. I forgot the exact number, so please, I will have to check it out if somebody wants to know the exact number. But it's the same thing as using jump and JSR, but in a closer way of the. If you have, normally you don't use jump and JSR in your code. It's very rare that you use them. You usually use branch or branch to subroutine on the 68,000. You'll use it if you're calling you use jump or jump to subroutine actually if you're calling some system routines. Oh yeah, they use a lot of cycles. Yeah. Yes, exactly, and they use a lot of cycles. That's why I said sometimes it's better to do shifts than actually using those instructions, but they are there. So yeah. Then there are instructions like test. You can test for memory location. And then there is branch on equal and branch on not equal, same like what we have on the 6502. So here he's giving a hint of what type of instructions you will encounter on the 6000. The good thing about the 68,000 is that many instructions are like the 6502. So if you know 6502, you know a big part of the instructions of the 68,000. So I remember myself, I knew 6502, and when I jumped to 68,000, it was easy for me, while Crane, who was on 68,000, I mean, I'm talking about Phase 101 members, while Crane, who was on Z80, when he jumped to the 68,000, he found it very hard to understand the instructions because the Z80 is like it's completely different, and it's a CPU that I do not like. I make an effort to follow Shalan doing Z80. It's only because I like the Game Boy. But unfortunately, as Shalan says, they use the wrong CPU. Okay, so here he's going to give an example. The ones in blue is basically explaining what he says here. So here he's using branch to subroutine. Yeah, Game Boy is only half at Z80. Good one, Andy. So here he's going. This is how to say. This is not a real example. Okay, he's just trying to explain the branch to subroutines example instead of using the jump to subroutine. So basically, here he's jumping to campaign. So we jump to here, then we return, then we jump to aspetta mouse, which means wait for mouse. So we come here, we do something with the mouse, we wait for the mouse to be clicked, then we do Pavarotti, which means we make some sound. So it's just, as you can see, they are all subroutines using BSR instead of JSR as we are used in the 68,000. That's all what he's explaining there. Let me see if there's anything that I wrote. He explains, so here there's another example. He explains test and BQ. So basically we test for a byte. If it's 0, here in this case is the byte at location labeled 30. So I assume we have somewhere location 30. No, he didn't write it. If it's 0, then if it's 0, we jump to here. Okay. If not, we return basically. So this is just a fictitious example. It's not a real example. Just to make you understand how branches work on the 68,000. I'm just going to see if I missed anything. Like branch on equal, okay, so here we use the instruction branch on equal. There is branch on not equal, and he is mentioning it here. The reason here he gives a robot trying to make a pizza, or something like that, and how to the robot how to know when it's ready or not. So basically, when it's equal to 0, so basically it's the same temperature, then it does something. But anyway, we don't need to go into that that detail. As you can see, on the 6502, okay, I'm just going to bring this example. Actually, this example, sorry. These two, so we could have, if you notice this instruction, when we jump from here to here, this could be a subroutine. Okay, normally it is not in the 6502. Okay, it's just a jump to a place which is close by, but on the 68,000 it's easy to create a routine, and you keep the code much more cleaner in a way by having two subroutines depending on which branch you take. Okay, so this could be a subroutine, and down here could also be a subroutine. So if you notice, you see there's an RTS here, and here there's also another RTS. So basically he's saying it's nice that we can jump and organize the code in a way that it's more easy to understand it than like what the 6502 permits us to write, which is true, but it works for the 6502, so it's fine. Okay, we are a bit ahead, so I'm glad about this. I still don't think we will finish it, but yeah. Yeah, so this we covered. They can become routines here. Okay, so basically the book is defining what a routine is. Basically, it's a block of code which we can execute whether we jump to it, whether we branch to it. It's just a block of code which we do depending on a condition. That's what he's saying. He gives he uses an example of a submarine. When he sees an enemy ship, how he arms the missile basically. So let's say each block, so he saw a submarine, he saw the enemy, so it's a block of code, he starts the init missile, for example. Then he needs to fire. When the missile is ready, he needs to fire, so then he executes the code of fire and things like that. So that's what he's saying here, and then he jumps into the code of the robot. So I do not need to really explain those. In fact, look, boom, when he fires the missile and hits, he's just making decisions on blocks of code. He's explaining that. Here it's another example of here he's talking about the robot making the pizza. So here he has a branch to subroutine to do something, then another branch to subroutine to do something. So these are all blocks of code, as you can see, like this one. Spaniel Forner means switch off the oven. So when it is ready, we can branch and do that part. And we continue doing those things basically. Block of code. So he's giving more examples of block of code. We've done that. So he's saying that subroutines make the code more descriptive, logical, and you can also create a library of these to reuse, which is true. A block, most libraries are made up of lots of little routines. If you jump to an area in memory where you should not have not jumped, or you have the wrong address, an odd address instead of an even address, and all those things, normally you get guru. Sometimes you get software failure, but the software failure will give you the guru anyway. So it's very rare that you recover from a software failure if you are doing hardware programming. If you are doing OS programming, software failure can recover you, but when you are doing hardware, it's very difficult to recover. So normally you just reboot. Here he's explaining what I just told you about the memory, where it goes, where you can code, so you can decide whether it's chip RAM or fast RAM, or slow RAM if you want to call it like that. I prefer to call it fast RAM because it makes more sense in a way than slow. But yeah. So here he's saying, okay, here he's saying that the Amiga 500, so this is what I basically explained. He's saying that the Amiga 500 with Kickstart 1.2 or 1.3 has got 512K of chip RAM as standard. If expanded, as somebody said here, it will go up to 1 megabyte, and the extra 512 is fast RAM or slow RAM. Slow RAM, actually, I should have written there, but yeah. This is why if you have only 512 megabyte of kilobyte of chip RAM, that another example mistake there from me. I'm not used to use kilobytes anymore, so I write megabytes. It finished. That is why if you have only 512, yeah. So basically, if you have 512 kilobytes of chip RAM, your memory finishes very quickly. Okay, a standard Amiga with 512 kilobytes of chip RAM, the memory I remember this very well till I bought first the expansion memory and then the GVPA 530. Yeah, it was a nightmare how quickly it finishes. You can maybe do each screen uses about 50K if I remember correctly. So I mean, if you're using 5-bit planes, so you can easily run out of RAM. If you have Deluxe Paint and you open 2 screens, that's it. Basically, you've had it on 512K of RAM. If you have 1 megabyte of RAM expanded the A500, then the program will be why it's 10K NTSC 8K PAL. Yeah, PAL is 10K, yes, and NTSC is 8K. Yes, you're right. Yeah. So yeah, that's why I said 50K, because if you have 5-bit plane, I remember it was 50K. But yeah, oh my God, my voice. Yeah, it's you have 256 or even more actually. You can go up to 300 lines, I think, on a PAL screen. Um, I mean, if you use the hardware direct, I think you can open, not I think, you can open more than 256 for sure. I can't remember if it goes up to 300 or 314 was the maximum screen that you can have in the Y direction. No, I'm not talking if you use interlace. I'm talking if you use standard. So basically, you'll have the borders. Um, let's put it this way. I think you can go up to 314 lines on the Amiga, but I'm not 100% sure. Oh yeah. So yeah, you agree with me. um, yeah, the 500 had 1 MB chip RAM. So here is I'd make a note to show you the memory map, which I already showed you, um, which I already shared with you guys. And then here's the memory where it is. Sometimes he doesn't mention it, so I'm ahead sometimes. So I know he mentioned the memory addresses here, but actually in my notes I wrote the memory addresses before. So for me it's better. Also I want to learn the things, so writing it twice gets better in my head. Um, for those, I'm noticing that since I spoke last, I'm noticing that there's lots of people that joined from Facebook. Um, if you are on Facebook, I suggest you switch to Twitch because there's a lag on Facebook. It's not. Also, you do not see my links. Um, yeah, if you like what you see, please do a like or follow me. I would appreciate. I just noticed somebody that just logged in. Ciao, Giuseppe Stasi. I hope you are enjoying my stream in English. This is episode 2 of the Amiga 68000 assembly. So the memory, okay, as I said, um, he always talks about the 500 because the 500 was the most sold machine and the machine that everybody had. Always refers to from 0 to 80,000 K is 512, and if it's expanded, it's the memory, which is called slow RAM, is 6 CO and 4 zeros and C8 4 0. That's where the memory is, the expansion memory that you add. Of course, all this is hidden, to be honest, from you. It's the OS takes care where the memory, how to move things in memory. But when you are coding doing hardware code, coding the hardware directory, basically you need to know this. And yeah, if you want to convert, yeah, this I didn't show you. If you want to convert a hexadecimal number to decimal or vice versa, there is the question mark command. So if I do question and I do 80,000, okay, it's going to give us that is in decimal. This is hex decimal, what it would be in ASCII if it was a byte, and here the binary value of that address basically, or that number, not address. Okay, so I think I will close with this last bit because this is, let's see. Yeah, so here I'm going to switch to something else. Let's see if this will work. So basically, I'm going to explain hex and decimal numbers and all that stuff. I mean, in a very short way. You know, if somebody wants to learn more, look them up on Google. But because he explains it here, so I'm going to explain it, things quickly. Yeah. Okay. So let's clear what I wrote. So if we have, first of all, I'm going to start with binary numbers. The symbol for binary numbers is the percent sign if I select a color. So the symbol for binary numbers is the percent sign. Apologies for my handwriting, first of all. And the symbol for hex, as you know, is $, and decimal doesn't have anything. So if we write a number in binary, I tend to write numbers every 4 bits. Okay, so a binary number is made of 8 bits. Let's put it, a byte is made of 8 bits. A bit can be either a 0 or a 1. Okay, so I tend to write a binary number in groups of 4. So if I had to write 1100 and then I don't know 0, 1 or 1, of course. Okay, so I tend to divide this. Okay, actually I'm going to do it like this. Yeah, so I tend to divide the number in 4, so that basically to convert it into hex is very easy. So we know a binary number starts, this one has got a value of 1, this one has got a value of 2, this one has got a value of 4, and this one has got a value of 8. So these two together is 12, and 12 is C. Yeah, 8086 and ZA. Yeah. I don't want to go into the politics of Z80 or 8086, but yeah. So that's a C. Okay. And this one, so if we do the same thing to 1, so, and this one, it's a 5, of course. Okay. So in binary, C5 is 11000101, and in hex it is C5. In decimal, that would be, so you need to do this. Oh God, I would do it. So I would do this now: 128, 64, 32, 16, 8, 4, 2, 1, and I would do that right on. Oh no, sorry, here. Imagine this is not there. And then I would do 0, 1, or 1. I mean, this is, I should have started from this, to be honest. And then if I wanted to do decimal, it's C5 like this. Yeah. So this is, if I had to count it all, it's 128 plus 64, that's 192 plus 5, so it's 197. Okay. Yeah. A byte is 8 bits, okay, and each bit has got this value. So let me erase. So if I erase this, okay, and then select the color again. So a bit and a byte, okay, is 8 bits, which each bit has got this value on top. Okay, so it's very easy to count. Okay, so in my case, I only count it when there is 1. So 128 plus 64 plus 4 plus 1, which makes it 197. Okay, so that's a quick way of converting from hex to binary or to decimal. Just for your info, when it's 4 bits, okay, it's called a nibble. I hope I'm saying it right in English. But yeah, and when it's 8 bits, it's a byte, as you know. But remember that the percent sign and the dollar sign is for, this is binary and this is hex, and decimal numbers has nothing, okay? That's basically it from what he's saying here. Actually, there is more. Okay, let's bring that back and erase what we have here. Okay, I was saying that there is dot. I was saying that there is dot L, dot word, and dot byte. This is 4 bytes. This is 2 bytes, and this is 1 byte. Okay, so a word, which is, remember, a word is if you have a move instruction, okay, and we do not specify anything after it, it's always, there is always this dot W, okay? There is always dot W. Take it a habit to always specify the length of the instruction. So always specify dot L, dot W, or dot S, okay? Remember also that a memory address is just 1 byte, okay? So when we do move.l, okay, move.l, well, okay, new lap, sorry, I cannot say your name, Nula Petus. It's okay. Yeah, if you started on Z80 and then jump to 6502. Yeah, I'm not saying it's bad, it's Z80, I just never liked it for some reason, personally. Anyway, so when you do move L, okay, remember, and you specify an address like 10 and comma $16, okay, you are actually moving 4 bytes, okay, so you're moving 10, 11, 12, and 13, okay, so move L will move the bytes, the contents of 10, 11, 12, 13 to memory address 16, 17, 18, 19. It's quite easy to forget this, okay? Or maybe it can be confusing. So it depending, because in 6502 we are used to always a byte, okay? We always move a byte basically, but in 68,000 you can move a byte, you can move a word, or you can move a long word. That is quite a big difference from the 68,000, from the 6502. Oh, wow. Not the 68,000. Let's see if there is more. Yeah, so basically it's what I said here. Dot byte means we're gonna byte value, dot word on 2 bytes that I worked on. Okay, thanks, New Lapitus. I will be finishing soon. But yeah, I'm trying to be a bit ahead. Okay, so here he gives an example of when, actually this is quite good what he shows here. He's moving from 10 to 16. He's doing a move L move long from 10 to 16, and he's showing address 10 has got the letter C, address 11 has got the letter A, 12 and 13 has got E, and he is moving in 16, which has also got something. So he's going to move these letters. When they move, they will be in they will form this word in a way. So as you can see, they were copied here and here. Okay, he, instead of long, he's doing a move byte now, and he's moving from 20. So 20 we had the 0, okay, or the letter O, and we're moving it to 14. So basically both words becomes the same now. Hound dog, yeah, sure. Yeah, I'm going to finish anyway, so it's fine. Um, so that's another simple example of how to move. I mean, basically what I had explained earlier. And he is explaining what I just said. He's saying that these bytes are 0, okay, just to assume that they are 0, basically, which we did. I'm going to end up here because this is a very important thing, which I think this is the third time that I'm going to say this. Basically, if an instruction is not on an even address, you will be faced with the guru meditation. As Andy said, it's a bus error, which the Amiga doesn't tell you it's a bus error, but it's a guru meditation. And with that, we end our lesson 2, which is more than 2 hours that I've been going. We did actually quite a bit more than the Italian version, but we didn't manage to finish the chapter, unfortunately. So thank you very much. As I said, those that are on Facebook and would like to join on Twitch, please follow me on Twitch. As I said, you'll get, I think there is more benefit on Twitch than on Facebook. I'm using Facebook because I know that my followers are on Facebook. But yeah, I'm going to end up the usual with the thanks to all the people that helped me in doing this. And there are some people that actually didn't really help me, but actually I learned from them. Okay, so as a thanks, I need to thank them. I feel I need to thank them because it's a way of thanking somebody for all the effort that somebody does, an appreciation of what they do. So thank you very much. Have a good evening, and see you next time. In 2 weeks' time, there will be episode 3 of the Amiga 68000 assembly course. And hopefully we'll finish chapter 1 and we start number 2. So you will start using the assembler now for sure. Okay, see you. Bye-bye.